Still on the uses of dimensions, we are looking at the second example where we are still using dimensions to derive equations. Yes. Now, we are saying that show that the velocity of sound produced in a stretched string depends on the length L of the string, its mass m, and the tension T in the string. So if you can remember, this is like one of the equations we showed that we are dimensionally consistent. Now it's time they are telling us to derive. Now, maybe the velocity of sound here is v. So they are telling us that v depends on the length L. This is power what we do not know. Then also it depends on the mass of the pendulum, is to power y maybe, and the tension T to power z. Now, to remove the proportionality sign, we bring in a constant, which constant we assume to be dimensionless. So, this is the expression that we have. Now, we are going to use dimension analysis. We are going to use a dimension analysis to bring out an expression that relates the length L of a string, then the mass of the string, and the tension in the string. This time our T is standing for tension. Now, let's proceed. That for dimensional analysis, let's try to get the from dimensional analysis, we know that the dimensions on the left hand side should be equal to the dimensions on the right hand side. So let's begin by maybe getting the dimensions on the left hand side. The dimensions on the left hand side are the dimensions of velocity v, whose dimensions we know to be L per t. We know that that is the dimensions. We know those to be the dimensions of velocity. Now, also, let's try to get the dimensions on the left hand side. I mean on the right hand side, dimensions on the right hand side are equal to dimensions of k times dimensions of L power x times the dimensions of m power y times the dimensions of tension power z. Now, if we assume that k is dimensionless, then that is k, L length is whose dimension is L power x times capital M, which is the dimensions of mass, power y. Then tension is a force. So the dimensions of force are m, L per t squared. This is power z. We do the mathematics here. This is L power x times m power y times m, when we open the bracket, power z, L power z then t power negative 2z. This is what we get from from opening this bracket. Now let's collect like terms. I can see L here, I can see L here. So this will be K L X times that one. When the bases are the same, we definitely add the powers. Then next is M. We realize that M is common. This is M power Y times M power Z. We are going to add the powers so that we have M power Y plus Z. Now we are left with the time or the period. We only have time once, so this will be the period power negative 2z. Now from here, for dimension analysis, we are going to equate the dimensions on both sides. So here we shall say equating dimensions on both sides. We are going to equate dimensions on both sides. Now, we said K is dimensionless. Let's begin with L. We have L on the left-hand side and L on the right-hand side. So for dimensional consciousness, we know that the dimensions of, for this quantity, its power should be equal to the power on the other side. So this one tells us that, so we shall say for L, we realize that L power 1 should be equal to L power x plus z. So when the bases are the same, we equate the powers. Therefore, x plus z is equal to 1. So this can be our equation 1. Then we proceed and look at, we consider M. On the left-hand side, we do not have M, and we say this translates into the power of M on the left-hand side being 0, and anything to power 0 is 1. So 1 times this whole expression, it remains the way it is. So we move to the next. On the right-hand side, this is our M. M is y plus z. So this is M power y plus z, which gives us an expression y plus z is equal to 0. I call this the second equation. So we are left with the t, this on the right hand side. So we are going to say for t on the left hand side, it is t power 1, which will be equal to t power negative 2z. And this tells me that negative 1 is equal to negative 2z. We divide through by negative and we realize that z is power half. Z is power half. Now we look at our equations. Equation 1 has z, equation 2 has z. Therefore, let's begin by substituting for z in equation 1. So we say substituting for z in 1, I'm going to have x plus a half is equal to 0, and mathematically this tells me that x is a half. This tells me that x is also equal to a half. Now I have the value of z. The only known I have here is y. Let me also substituting for z in 2. Y plus z is equal to 0. So y plus a half is equal to 0. Mathematically, this tells me that y is equal to negative a half. So now let's come back to our expression that we are trying to form. We said that the velocity v is equal to a constant times L. L is power x. But what is the value of x? This is L power 4. I mean power half. Then this is m power y. So this is m power negative a half. This y is like half. Then the tension T power z, and what is the power of z? Z was found to be a half. But we know anything power half is the same as putting it under root. Therefore, my velocity v is equal to k root into L tension T over mass. So this is the expression that we are talking of. And if you remember, we were at one time asked to show that such an equation is dimensionally consistent. So this is the expression they wanted us to derive. So guys, more examples are loaded on the articles on the website, whose link you can easily access. When you go and look at physical quantities and units, you realize that more of these examples are uploaded within there. So please don't stop at watching the lesson. Take notes, read through the article, answer those questions, and give me feedback. Thank you.